Welcome to solverfy.
So we are going to use this equation over here where the magnetic force is given by the charge times the cross product of velocity with the magnetic field. And magnetic field is out of the plane of the screen. That means that the velocity which is tangential to this path is perpendicular to magnetic field at all times. So we are so sine phi is basically 1 because phi is 90 degree, and this gives the magnitude of force to be q times v times b, basically q mod times v because uh, we are taking the magnitude here and charge of the electron is negative. So yeah, here, and the direction is given by right hand rule, which is, let's just write the direction. So if we apply the right hand rule over here, we'll see that the force is towards the center of this semicircle. And this gives, so let's like, the particle is moving in a circle, and for circular motion the acceleration is directed towards the center of the circle. So, and the centripetal force is exerted by the magnetic field, or we can say that the centripetal force is basically the magnetic force here because it is the only force acting on the electron. And yes, so let's do that. So we know that the net force is equal to mass times acceleration, and here the net force is q times p times v. And if we don't take the magnitude, f is going to be out of the circle, so that just uh, gets cancelled by the centripetal force, which is towards the center of the circle. So that's the reason we are taking the mod here, and this is equal to the centripetal acceleration, mass times centripetal acceleration, which is v square over r, where r is the radius of the semicircle. And this gives the magnetic field to be mv over q mod times r. Okay, times r, and we solve this and we get the magnitude of the magnetic field to be 1.6 times 10 to the power minus 4 Tesla. Now for the second part, so this is the first part. For the second part, the speed of the electron as it moves along the path is constant, as you can see. And the magnetic force changes with the change in direction of the velocity, but its magnitude stays constant because sine phi is always 1 and the rest of the values are constant. So the time is given by the distance divided by v naught. So the distance is half of the circumference, or pi r, and v naught is the initial velocity, and this gives the time to be 1.11 times 10 to the power minus 7 seconds.